Hey everybody, another day, another Leetcode problem. So today we're going to be looking at 127, that is word ladder. So this is marked as a Leetcode hard, but if you get the intuition right, it's actually pretty simple. So let's just jump right to it. So you're given a transformation sequence from word, begin word, to word, end word using a dictionary word list. So the transformation sequence is basically a sequence from begin word to end word, and the words in the middle are all words which should be a part of this word list. And so you have to find the length of the shortest transformation sequence to get to that end word. And it says that adjacent words have they have like a difference of one character. So I think it's better I just kind of illustrate this out. So yeah, what we're given is a begin word, we're given an end word, and we're given a word list. So the length of the shortest transformation sequence, where adjacent words, they differ by a single character. All right, so let's look at an example over here. So it's the same example they have taken. So the begin word is the word hit. So hit actually has 3 letters. I can replace each of these. So H can be replaced by anything from A to Z. And that can be like probably 26 different words. Or I can be replaced from anything from A to Z and so on and so forth. And if that's a valid word that can be part of the sequence, then we're going to add it to like our next layer over here. So hit can convert to hot. That's what we've done over here by turning I to O. And then hot can turn to dot by replacing the H, and it can turn to lot by again replacing the H. So we have dot and then we have lot. And let's look at dot over here. So dot can become dog, replacing the T, or it can again become lot, which is something we've seen over here. One thing that's worth noticing is that lot has already come here, and it had come here in the 3rd layer itself, but here it's coming in the 4th layer. So if I use all these elements that were like a part of lot and then use them here, it's simply going to increase the length of the sequence, which is not something we want. So that's something we have to keep in mind, because we don't want to repeat words again if we've seen them already, because what's the use of creating a larger sequence? It sort of defeats the purpose of the problem. So yeah, so let's look at this. We're here at dog, and dog can become log, or it can become cog. And cog is actually the end word that we are looking for. So we have covered these words. And if I look at the transformation sequence here, we have 1, 2, 3, 4, and we have 5 words that it took to get from begin word to end word. And the answer is also 5. So yeah, that's basically what the question is asking for. And it's worth noting that as we were traversing through this example here, everything is happening layer by layer. So this was the first layer, and then replacing like one character in any of these positions would have led us to the 2nd layer, and then the 3rd layer, the 4th layer, and this was the 5th layer, right? So, and these would all have come in the 5th layer. So we need to keep track of the layers, and we don't want to repeat words. We do not want to repeat words as this increases the sequence length. So let's go ahead and like mark visited or somehow track this, right? So yeah, I think this problem is much better when it's written in code, because that makes it very understandable. So let's go ahead. One thing is that they've given that begin word, and then begin word might not be part of this list, but we know that end word has to be a part of the word list, because if it's not there, then we can never really form it. So let's put that as like a base case to just return our default value of 0 if it's not possible. So let's say if end word is not in word list, then let's go ahead and return 0. That's what they've asked for. And I see that I will be repeatedly accessing our word list to check if any new formed word is a part of it or not. So if I check that in word list being a list itself, then it's O of n times. So if we could do this once, we could convert word list to a set so that our average lookup time is O of 1. And what else did we want? We are looking for a result, which is the number of layers, basically the depth. So it's 1 to start with, because we at least have a begin word to start with. And we are going to be doing layer by layer. So that's a breadth first search. So we can do collections, PQ. And we will start off with the begin word. Okay, and we will increment it layer by layer. So one thing I mentioned that it would be nice if we could have a visited set. So instead of that, I could just use the word list itself, and I can remove it each time I do encounter a word, which is a part of it. So we'll use that as like our visited set over here. So yeah, let's start. While Q. So as I mentioned, any character that is changed in like this layer, which could be like 26 by changing the first letter, 26 by the second letter, and the third layer, all of this does just come in the second layer, which means one change, one letter change. So that makes them adjacent to each other. So I want to finish all of those to make it the second layer. So I'll do for I in range length of Q. This guarantees that I finish my layer. Okay, so the word that I'm dealing with is Q dot top left. So I get that word, and I want to check if that word is the end word itself. Then I want to return the result or the depth that I have, or else I want to form the next layer, right? So I do if word is the end word, then I can go ahead and return the result, or else I want to do my calculations, right? So I want to go ahead and replace each position of word with any of the existing alphabets, right? So let's do for J and range length of the word. This can that position can be replaced by any character in E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So the new word that is formed is the old word up to J plus this character plus the old word again from J plus 1. So the J index is value, the position J, the letter at that position is replaced with one of these 26 characters. So now I want to check if new word in word list, it means it can successfully be considered in my sequence, right? So I want to do that. So I want to do q dot append new word, because that might be it's part of my next layer, so it's worth traversing. And I also want to remove it so that I don't repeat. So I want to do word list is basically our visited set here. So word list dot remove new word. Yeah, by the end of this, I would have finished one layer and like accessed all of that and created like their respective formation amalgamation the next layer. So this is where I know that I have formed a new layer. So once I traverse that layer and I probably find the end word there, then I would know that that's the actual depth to layer. So yeah, this is actually supposed to return here because we eventually have to find the end word. And so yeah, that does return result. But if we don't find the end word, then we can go ahead and probably return a 0. It shouldn't happen because we've done this check here already. But yeah, let's go ahead and check this out. Yeah, it does work. Okay, it runs. And so let's check the time complexity here. We do see that we have a lot of loops here. So Q can basically be, it can hold all the words, maybe. So that's, let's call that W. And then for the length of Q, yeah, so this is what happens. So we have W here. So let's consider the length of each word to be a maximum of L. And then we have like 26 here because of that. And then we see that we are doing like some string manipulation here. So that every time can actually take up L again, a time of O of L. So this together would kind of make the time complexity. What did I do? Yeah, so this would make the time complexity O of W into 26, which can be ignored later, time into L squared. Yeah. And then we have space complexity. Okay, so for each word, again, if we are like forming 26 here, and we are like forming a new word here. So this is where the space would actually come from. So yeah, I could probably say this is something like W, because it happens for each word, times yeah, the length of this word, because that's gonna be a new like string that's formed. So yeah, this is the explanation, and I really hope you guys understood it. Like I mentioned, if you understand the intuition, it's not that difficult. So yeah, thank you, and happy coding, everyone.